And also, wow, this is a difficult topic to explain just in half an hour. So let's start now. So this is the week of the last day of the week of mental health prevention and mental health comprehension awareness. And I would like to talk to you a little bit more about this precious resource that you have, your mental health. Because you all know that if you don't feel well and you don't feel happy in your everyday life, it's very, very difficult to be productive and to dedicate your life to the career that you deserve. So, what are our objectives? What is actually a functioning human being? What does it even mean? Sometimes we think, oh, a functioning human being is the human being who is happy. And there was a great talk last year on this very stage of HackConf about debugging happiness, talking about all the proven ways to feel a little bit happier. But this year, there is a clinician who works with people from different backgrounds and with different problems, who comes here and blows things a little bit and explains how all the proven ways to feel happy sometimes backfire and sometimes don't work, and this is completely understandable and completely normal. Well, what is happening? Happiness? Well, it could be summed up as a consequence of active and responsible seeking of positive emotion, engagement with others, building relationship, finding meaning, celebrating your and others' success. And you can easily think about happiness as Freud explained it, as experiencing pleasure and avoiding pain. But is it all about sex, drugs, and rock and roll? Not really. The problem is that very soon even Grandpa Freud figured out that many of us actually don't really do that. Most of the time, we do things, actively do things to feel shitty. And this is weird. So this is how psychotherapy began. Well, what else actually makes us happy? Well, it is proven that experiencing the flow is something that makes us very content, makes us enjoy our work. It really gives us this energy. We feel alive. We really feel connected with our job. But we think that the flow is doing something difficult with a huge challenge level, and we perceive ourselves as very skilled persons, and we experience the flow. If we are skilled and we do something difficult, we enter in the state of flow. In reality, there is a very, very, very important word over here. It's not challenge level, but perceived challenge level. It's not skill level, but perceived skill level. For many people, many of us, well, we don't go to this point when we feel that we do enough and we are capable enough. And therefore, flow is more difficult to achieve. Well, we can think about all this in terms of sociology, developmental psychology, neuroscience, genetics, and epigenetics. But in many occasions, even if we live according to our values, nothing makes us fulfill. So, we are confused sometimes because when we see Maslow's pyramid of needs, we think we are confused and we think that we just climb up the stairs and once we've achieved one thing, there's another. And another step, and then on the top of it, we feel self-actualized and mature enough to be functional and happy. This is not true. In clinical practice, we see all the time how people who have problems experiencing trust towards others and experiencing closeness and experiencing empathy, they could never feel safe, for instance, no matter how self-actualized they are, no matter what their self-esteem is. So it's not exactly a pyramid that you climb. It's very personal. Well, according to Erik Erikson, this might be due to some stages in maturity, and there are positive and negative outcomes. If you have negative outcome, you're pretty much screwed. According to neuroscience, it's very complicated because people's nervous system is much more complicated than it is said to be in the motivational talks and some self-help articles, because it's not really taking a pill of dopamine or serotonin like you take vitamin C that will prevent you feeling bad. It's actually much more complicated. In reality, your thoughts and your physiological response to the thoughts create a closed loop in which if we think that we feel shitty, we can actually provoke our body to release stress hormones, and then the stress actually makes us feel even worse. So how do we break this loop? Well, it's complicated. So let's move on. It's important to know in what ways exactly we can crash. So we can intervene in the moment when we are not really sure what is going on with us, but something is wrong. Well, there are more than 300 ways we can break, and this is only according to diagnostic manual, which only covers the clinical conditions. Well, it's very likely to not feel okay. Actually, 13% of the people are experiencing mental health problems. Depression, 3 or 4 in 100 people are experiencing just right now. Anxiety, alcoholism, schizophrenia. But as you see from this chart, that only a couple disorders actually might, in certain conditions, lead you to lose track and lose connection with reality. Most of the conditions actually don't make you experience any disturbance in recognizes what is real or what not. Nevertheless, they are very serious. Well, in depression, this is just this one voice that tells you that everything is pointless. All the feelings that you feel are negative, or if you feel a positive feeling, you just ignore it. Depression is like being numb. It's like this monster next to you in the bed who tells you that everything is pointless and you are a failure. And then again, we use different things to cope with this. Well, I like memes, for instance. Anxiety disorders, also very, very common condition. And I can tell you that myself, I am a person who is not unfamiliar with anxiety, not only as a clinician, but also as a person who perceives, most of the time. Now, for example, if I let my anxiety just go wild, I would probably think that you are all here to judge me and to tell what is wrong and what I've got wrong in this presentation. Well, it's not exactly the case. But the problem is that anxiety is not a bug, it's a feature. It's totally normal to experience anxiety. The problem is when it goes wild, and this is when we treat it. But that's why it's one of the most difficult conditions to treat, because it's actually something very normal to experience from time to time. As you see, I think that most of you have been there in some of the settings. I'm usually the chill one. Yeah. That one in the middle. Well, alcohol and drug abuse. When do we know? When our recreational habits of drinking or taking some kind of drug is actually a problem. for me as a clinician, I would say in the moment when you start self-medicating a very serious issue by ignoring it with the help of alcohol and drugs. And then again, there are multiple other ways to feel really bad, and these are not clinical conditions. There are not pills designed for them because it's a question of your mind. It's not a question of your body. Well, like too much gaming, coping with traumatic experiences, irrational fears, passive-aggressive behavior, just to name a few. Damaging body image is something that we fight with, most of us, but for some people it is so incapacitating that they cannot go out of home because they feel ugly this day. Some people feel unhappy with the way they look to an extent that they think that nobody will love them the way they are. Nobody will ever feel attracted to them. They're disgusting and they don't deserve to live. But the question is that we actually really need to feel the way in which this parrot looks at himself from time to time, not all the time. It's okay to be critical, but in small amounts. The symptoms of burnout. Well, you are all young, and well, I'm not much older, but burnout is it's a very serious problem. Most people I see experience burnout up to a certain extent. And the possible causes could be lack of recognition at work, could be too much work, lack of control. But one of the causes is actually loving your job. Because when you start a job that you love, you perceive it as something perfect, that will make you happy, that will make you really fulfilled. And no job can do that for you. Of course, we can be happy with our work, but it won't sell. It's impossible for a job to solve other problems for us. How can we know that we are stressed or burned out? The stress is just exhaustion, physical exhaustion. The burnout is feeling that everything that you do is meaningless, that you don't want to get up from the bed. It's very similar to depression sometimes. It's just you're dried up and nothing that you do makes you engage with your work. So it's also very important to treat it if you are perceiving this. Yeah. Sometimes I feel like Sisyphus, like working for home when people don't get well soon enough. Impostor syndrome, well, happens to much more people than you expect. It is when you feel that you don't deserve to be where you are, you don't deserve the professional recognition that you are receiving, you are worthless, and everything that you've done is a lie, and some people just believed that you are capable of doing your job. In reality, not that much. This is also not a way to feel about yourself. You can't feel about yourself this way. And talking about relationship issues, I can't even start talking about relationship issues, so I will just throw 3 memes here, and I hope you understand. People who date the wrong people, who people are passive-aggressive, people who just cannot open up to anyone because they're scared of the connection. Well, if you're one of those, well, you're not alone. So, who can help? Who troubleshoots that? Who is there out there? Well, family and friends. Sometimes you think that your family and friends should understand you when you talk about your emotional problems, but actually everybody is just as confused as you are. So the thing is not exactly to look for comprehensiveness, but just to practice talking about your problem, just being vulnerable, because there is huge, huge strength in showing vulnerability. And it gets better. You come out with your anxieties and depression, talking about it to the people who are most close to you, and it becomes easier and easier, and in a certain moment you look for help, professional or emotional, or you get better eventually. Well, older people sometimes don't understand. Most of the parents of my clients say, oh, well, what's that? This is just talking to somebody. It's just totally pointless. Just man up and do it. Well, the truth is that in Eastern Europe, nihilism is not a question of choice. Older people very often are very nihilistic, and they just forget that they have been young with strong emotions and problems themselves. Don't look for comprehensiveness. Look for the attachment, to re-establish attachment with the close ones. You can use humor as much as it doesn't mask your feelings. And, well, you can move on. If this doesn't help, well, of course, there is self-help. There are many places where you can look for information. Books, articles, TED Talks, HackConf talks. There are 2 of them already about mental health. And, well, also coaching. Why I put coaching in this section? Because coaching practices usually are designed to work for as many people as possible in a way in which self-help book is designed. And they are investigated to work or marketed to work. Well, depends on the coaching practice. But the important thing is that they are tailored towards a certain framework and practice, and not tailored exactly to your own personal problem. Let's not forget that we all break in a very, very unique way, no matter what. Nevertheless, we know that many people experience these feelings. Here you can see what Charles Darwin said: I'm poorly today and stupid and hate everybody and everything. Well, so, if we cannot go through what we are experiencing through our connections, if we cannot cope with the help of all the information available, sport and exercise, mindful exercises and everything that you can find useful, well, you can go to counseling and psychotherapy. Counseling is usually a little bit shorter term. Psychotherapy is longer term. Usually psychotherapists study 6 years in university and 4 years additional in private schools, in which they learn how to debug you. Well, but how do I choose? And can I do it from home? Good questions. Well, there are many types of psychotherapy, and people who feel that the need to talk to someone often feel confused. Why they are so different? Well, there are different schools of psychotherapy, more than 50, with more than 200 different types. The most common and the most famous are psychoanalysis and CBT, cognitive behavioral therapies. I will just talk about these 2 because I really don't have the time, but most of the therapies derive from one of each, or are close to the concept of one of each. CBT is usually shorter terms. It helps you identify the patterns, the behavioral patterns that you have, and teaches you to practice more healthy behaviors. Psychoanalysis doesn't care so much about certain trigger and certain behavior. Psychoanalysis cares about what is the logic inside of the person's seemingly illogical behavior. So, look at this guy over here. Yeah, this one. Yeah. Well, he's confused. This is the brain of an imaginary client of mine, Bobo, who just came this morning with a very serious problem. Bobo wrote 75 messages to his ex-girlfriend last night at 3 in the morning and got blocked. So, yeah. Well, enough with the pleasure principle. It's not pleasurable to look at your ex's Facebook page 5 times a day, but, well, this doesn't reduce pain. So it's obviously something is wrong. What happened? Well, if I were a CBT therapist, I would talk to Bobo and figure out what's been going on. And he will tell me that he worked all day, all week actually, very, very busy, 12 hours a day, putting all the effort in the world in his job. And he was so tired and exhausted, and he wrote these 75 messages, and this happened. Well, then we will talk about how certain parts of the brain who are responsible for the analyzing of which activity is socially appropriate and which is not, are not that active when he is exhausted. So we will do some exercises and I will tell him what to do to calm down next time it happens. And eventually he will be better. So we talk about triggers and we talk about the behavior pattern. But I'm his psychoanalyst. And we will talk about, well, you worked so much. How so? Is it a busy week? No, not that much. Well, what happened? Well, in the beginning of the week, Facebook spitted a photo of an old vacation of ours with my ex, and we were so happy back then, and she told me that even if we are away, if we look at the same stars, it's like we are together. And I trusted her so much that we will be always with me. And I really felt like I was a little child. I was with my family. I felt safe. I felt safe with her at that vacation. And I spent the whole week working and working and working and working. And that night, I just saw the bright moon outside of the window, and I snapped, and I started writing and writing and writing. And I was completely sure that after each message, she will respond. But she didn't. Well, two different approaches, both of them proven to work, both of them take time and effort, and nothing is miraculous. But, well, here we are here to help. Well, can we do it online? Well, as we mentioned, I am a part of international organization of online therapists, and we dedicate our practice to working with people who travel a lot or just prefer to receive therapy in the safe place of their home by video chat. Of course, it's not for everybody. For those of clients who don't really feel that this is enough for them, we recommend them to go to see a therapist in their town, if it's possible. If it's not, we are there to help. And of course, the very, very severe issues that cause sometimes losing contact with reality, as schizophrenia and bipolar, sometimes very, very in very rare occasions. Well, this is not exactly recommendable. Well, for people who need to take drugs or be hospitalized, there is another level of help. This is psychiatrists and clinical psychologists. Psychiatrists are the only professionals who are with medical degree, so they are the ones who give pills. So they can prescribe pills. But the case is that sometimes people really experience huge stigma about taking psychiatric medication. Sometimes people just need it for depression and anxiety. There is no stigma in that. And of course, many people who live with schizophrenia and other very, very difficult to deal with disorders, most of the time, due to good medicating, actually feel very, very well and don't need, people wouldn't even recognize that they have a chronic condition. So what I really hope is that the stigma will be totally removed very, very soon. Because nobody is actually normal. There is not such thing as normal. We are all unique in a certain way. And we have all quirks and we are strange. But can I see those professionals who usually work in a hospital setting from my home? No, because you shouldn't take health advice on the internet, and especially regarding psychiatric medication. Well, I'm here if you have questions. And if you want to ask your question more privately, you'll find all my contacts, LinkedIn, Facebook page, email address, encrypted one to be completely, private in my website. Thank you so much.
All right, so do you want to take questions from the audience? We have still 30 minutes to go.
Mm-hmm.
All right, questions? Over there. Ready?
Hello.
Hello.
I wonder if there are certain psychological disorders which are only observed in modern societies, as opposed to, for example, in hunter-gatherers.
I'm sorry, but I hear awful echo where I stand.
Can you talk slowly?
All right. I wonder if there are certain psychological disorders which are only observed in modern society, as opposed to, for example, hunter-gatherers. And vice versa, if there are certain psychological issues which only hunter-gatherers had, but which are not observed in our society.
Oh, that are existing. Whoa, there's it's a strange place where I am. That exist now and they haven't existed 100 years ago, or that have existed 100 years ago and not now. Because both, yes. It's funny thing that most neurotic behaviors, neurotic behavior is as opposed to the clinical conditions that most certainly have some physiological factor. They're very fluid, and it depends a lot of the society that a person is developing in. For instance, 100 years ago, psychiatrists were dealing a lot with paralysis that was not at all connected to any physiological condition. Under hypnosis, a person could walk and talk, but because of some psychological issue, cannot perform the same one. Well, this is almost gone. We don't notice this anymore in the clinical practice. It's very rare. Well, of course, now the anxiety is just plummeting. The anxiety is really exploding right now because, well, we have very, very serious stressors. For instance, we don't feel secure in our job place because it's just we change jobs every couple of years. And our parents, they worked at the same place for 40 years. There were many functional alcoholics who just kept their job. Now, if we have any issue at home or in our head, we have to deal with it immediately because job market is just so active. And there are other issues with being all the time connected, with losing contact, with physical and emotional contact with close ones, with neighbors as well, the community. Well, there are many issues that, but they are specific. So the basics, more or less, the functioning of the brain is the same. So we just find different ways to feel bad.
Right, thank you. More questions?
I'll try. Thank you for your presentation. Can you share some advice on how to, I guess, encourage someone that you notice some strange behavior or change of behavior in, let's say, friend, not in close relatives, but distant friend, colleague, whatever, that you don't have an immediate connection to or something like that?
So close friend or not that close friend?
Try both. Try both. Mostly for a colleague, for example, or a distant friend.
Because this is a very certain way to lose a friend, you know. People don't like to have their psychological issues pointed. I would say critical thinking, just not pointing in somebody's face that what he or she does is seemingly irrational, because inside, as I said, inside there is a very, very serious logic. If I shout at my boyfriend every day, my logic is that he's irritating me and he's being a bad boyfriend. I wouldn't think that I have a psychological issue. So probably exposing person to different experiences, different points of view, and eventually, well, pointing just a little bit that you know people who went through this and things changed. But it's very tough one. I get this question a lot by email. How do I convince my husband or daughter to go to professional? It's not that easy. It's one of the tough ones, and we don't know exactly how to convince a different human being. It's something that you get to realize yourself.
Hello and thank you. Is there
Awesome.
sort of like a way to, if you've already decided that you would need to seek professional help, like choose the right professional to help you? Because you would have to build trust with that specific professional and be able to talk openly with him. And you don't want to find yourself, for example, 3 months into the sessions and find out that this is not the right person to help you. How do you go around choosing the right person to help you?
It's very personal. First of all, you go to a person who is actually very well educated in the topic. You seek a professional who's been through all the 6 years of university training, probably PhD, but not necessary. It's not necessary. And also who goes through a very serious practice. And this guarantees you that the professional is qualified. Then again, trust your gut, because sometimes we get to work with somebody who is actually very, very well qualified, but is not just a good fit. If you just feel that this person you cannot work with. You know, when you have a new colleague and you say, yeah, that's the person I would like to sit next to, and this is the person I would like to have projects with. And sometimes there is some new person who is just meh, and I don't trust. And if it's like that, the first sessions, you probably, in psychoanalytical terms, have a negative transference. Just go to equally qualified person and go with them. A very good thing is to try a few. In the beginning, most will meet you, some professionals meet you for free, for just 15-minute conversation at least, so you can decide if you are a good fit. So you pick a qualified one and go to 3 or 4. If you don't like anyone, so probably the problem is not in the professionals, but and just go with, if you like all of them, just go with your favorite, and yeah.
All right, we have time for one more last question over there. Jor was the first one.
No.
Check.
Thank you. Thank you very much for your presentation. I think mental health is very important, and I will just support what you just said. You need to try with the therapist. I personally go to, and my question is, I go to a therapist, and it highly benefits me in every field of my life. I just wanted to ask you about how do we change the perception that going to a mental therapist or psychotherapist or consultancy is a bad thing, because you said that Eastern Europe there's a nihilism, which basically means that your parents are like, yeah, you're fine, but this is stuck with you, because you know that suck it up and man up and do your job. How do we change the perception of the society that going there and checking if everything is okay with you is fine, and how can we speed this up?
The question is, do you want to start with people around you, or you want to start with society? Because, well, first you start with people around you. Of course, older people do not know that psychotherapy exists. For them, it's just a madhouse with all the nutcases and normal people. This was the understanding of their generation. The only way for them to understand, for all the people to understand, is just feeling that you are a more relaxed person. Also, it's important to point that in today's society, you cannot take 4 months of sick leave because you are just experiencing some psychosomatic issues. It's not possible. So it's very important for your career. It's very important for your relationships, and that's it. Just leave it there. Also, being open about it really changes, because some people really feel still ashamed, and we cannot blame them. But for those of you who are proud with the process and who are proud with the hard work they are putting in their experience under therapy, just spread the word, tell the others. It doesn't hurt. It's actually a pleasant experience once you get used to it.
All right. This was the last question, so please, big round of applause for Dr. Mila Petkova.
Thank you so much.
The last talk will begin here. We don't have a last talk in track number 2, so everyone's going to be here at 6, so 10 minutes. Uh, it's about time to start. So let's take your seat. Take your seats, please. We'll give 2 to 3 more minutes for the people just to stream in. So this is the last lecture, and then we're going to start.
Да, ты скажешь хип, но ты скажешь саму хип. Да, використовуємо. Да, да, да. А що такого, да? Скажем, скажем, много проблем.
All right. 1 more minute, please. Come in, take your seats, and we're going to start.
Bio, bio. Waarschijnlijk op zo'n systeem microfoon. Да, да, да. Как distributed system ceiling? Зашли подчас до стрема речи. Не пошел короче. No step.
All right. I see more people coming in, so please take your seats. We are starting soon. All right. So this is our last talk for today. Ivan Vergiliev is going to be our speaker. He's a tech lead at HEAP. I guess he will say a few more words about himself in his talk, but I want to say a few more words about him because this is the guy that got me into programming, and it's thanks to him that we actually managed to do something like HackConf. So please, a very, very big round of applause for Ivan.
Thanks, Carlo. Hey everyone, my name is Ivan. Ivan, whatever. We're gonna be talking about horizontal scaling, distributed databases, things like this for closing today's HackConf first day. So talk plan, first we're gonna go through an introduction of what the problem is that we're gonna be covering. Then we're gonna go through some fundamental concepts in scaling a data system and why these concepts are useful. And then we're also going to go through what kind of trade-offs they incur and like what kinds of things we need to think about when we introduce those things into our system. And then depending on how time goes, some extra credits, which we'll see what it is and what it isn't. Cool. Yeah, about me, I'm currently a tech lead at a company called HEAP. It's a startup based in San Francisco. One of the fun things is that beyond working with distributed systems, we also work with a distributed team. So I work in a team with 6 people. None of them is in, no 2 of them are at a single location. So I work with a person from Lithuania, Italy, San Francisco, New York, and a city somewhere close to San Francisco, but not there. So this is also pretty fun. It has some of the benefits and drawbacks of an actual distributed system, some of the similar failure modes and benefits. Before that, I was a tech lead and founding member of Nippon Sofia office. And before that, I've been at Google and Facebook for a few internships, SoundCloud when they had a Bulgarian office. And then I also, like from a while back, I have a bronze medal from the International Olympiad in Informatics. Cool, so let's get started. What's the problem that we're going to be discussing? We have lots of data and we want to store that somehow in a way that allows us to do useful operations. Usually somewhat abstractly defined because we're going to be covering fundamental concepts that apply to like all kinds of different systems. But in short, we're going to focus on cases where the data set is changing or dynamic, as in there are reads, but there are also writes to the data. If the data set is static, like we have a big data set and we want to analyze it, for example, that's a different kind of discussion. Some of the same ideas apply, but usually apply in a slightly different manner. Okay, so we've been doing a bunch of talks on distributed systems lately, and I also start them with a disclaimer. Distributed systems are hard. Like there are a lot of, like a ton of failure modes, a ton of things that you need to think about, a ton of systems that you need to administer and all that. And the other thing is that, like, in addition to distributed systems being hard, single system machines, like single instances, individual instances, are super powerful. So you probably don't need a distributed system. So just to give an example for this claim that individual machines are super powerful, Amazon, maybe last year, launched a new instance type, like a new type of instances, called the U6, 9, and 12 TB1. The .metal part means that, whatever. .metal part means that there's like almost no virtualization, so like you use almost directly the hardware underneath. And the thing that you see in the second field, the 6 terabytes, 9 terabytes, and 12 terabytes, I just want to underline that this is memory. Like this is RAM, like random access memory. This is not a hard drive. This is not an SSD. So you can go to Amazon, click a few buttons, give them your credit card. Like that's going to be an important part of that exercise. But with a few buttons and like some money, you can get a machine that has 12 terabytes of memory and 448 CPU cores. So you can do a lot with that. And if you can, you probably should. But then, okay, so that's a disclaimer. Now, if you actually do need to scale out, let's see what this is about. So we're going to cover like 2 fundamental concepts, and then we're going to go to drawbacks. The first thing that we're going to need to think about is that, okay, we have a lot of data and we have a lot of machines, so how do we benefit from like all these machines? Let's say I'm going to be giving an example with a big table called events that has 1 billion events in it, with an ID, a user ID, and a country for each, where each event happened. So let's say this table has like 1 billion rows. This is probably too small to scale out, but it's like easier to talk about because like after that numbers get more complicated. But like the first thing that we need to do is that we need to split it somehow in order to benefit from all the machines. And like a traditional way to split it is to say, okay, I'm going to take the first 100 million rows and put them in separate subtable, take the next 1 million rows and put them in separate second subtable, and then so on until we split all the 1 billion events into separate subtables. The subtables are usually called charts or tablets, depending on the system and who's doing the talking. And also, this is called horizontal partitioning. And there's like another type of partitioning that's called vertical partitioning. We're not going to be covering that here, but it's also useful in some situations. Okay, so we split the data. Then what we do, we take like 10 worker machines and put each table, like each partition, each chart on one of the machines. So that's pretty cool. Why is it good beyond the fact that we can like store more data? Well, it's easy, for example, to do something like a primary key lookup. Okay, so we have like this 1 billion events, but right now I only care about event number 100 million. So I want to read the content of this event. I want to see what country it's in. So that's pretty easy because I know that it's in the first table, like in the first chart. And I know if I know where the first chart is, I can directly go to that machine. So I can go to that machine and just query that machine directly, only like 1/10 of the data set, or like if I have more machines, even smaller part, and like do a single node operation only on that part of the data set. And then another thing that we can do is we can do machine level parallelism. So if we wanted to do something simple like select count star from events, like we want to count all the events on all the machines, we can launch this query on all the machines in parallel. So we can benefit from having 10 or 100 machines execute parts of this query for us. Okay, but then with great power comes great responsibility, Spider-Man and all that, which in our case means roughly you can't expect 100 machines to just stay up. You need to be careful about keeping the machines up. I'm going to give you a quote as an example. I'm not going to like throw statistics on mean time between failures, but like this is a quote from Jeff Dean, who is one of the more famous engineers at Google, currently a lead of Google AI. So in each cluster's first year, when Google creates a new data center, within the first year, about 1,000 individual machine failures will occur. Thousands of hard drives will fail. One power distribution unit will fail, bringing down 500 to 1,000 machines for about 6 hours. So you have 100 machines, maybe like they're just all done at that point. And also like another part that they wanna focus on is 20 racks will fail, causing 40 to 80 machines to vanish from the network. Like the network is another thing that's constantly failing in addition to machines. So like this is the Google scale, but you don't really need to be Google to hit this. At the company that I work at right now, we're like very far from the scale of the whole data center, but we still hit individual instance failures like maybe every once a week or once 2 weeks. We've heard from Amazon that this is because we're using one of the new instance types, so they're not stable yet. But like the fact is, we are using a production AWS instance, and it's like failing constantly. So how do we stay responsible when faced with so much machine failures and like all concepts of failure? Well, what we can do is like the standard approach is to use a replication. So the idea with replication is now instead of just keeping each shard on one machine, we put each shard on 2 machines. Like we copy each shard twice or 3 times or more, depending on how reliable we want to be. So now, if machine 1 fails, then we also have a copy of the shard 2 on the next worker as well. So we can recover that data from there. So why is that cool? In addition to like machines failing completely, we can also do like failover at query time. So if you're looking for the first event, like the first millionth event, which we know is on the first machine, but then while we're doing that, the machine dies, and it doesn't give us a response, we can just directly query the other machine that has this shard. Okay, this is all pretty standard. The next thing is like another benefit of replication that's like a bit more unpopular is something called speculative execution. And the concept behind that is that any individual machine can be very slow at a given point in time. For example, maybe right now I have queries that are only hitting 1 machine instead of all 100 in my cluster. Or maybe there's like garbage collection and background system processes running on that machine. Or like all kinds of stuff can make a machine slow. So the idea here is that if we want to query for event number 100 million, or just 100 or whatever, we can, instead of only sending a request to worker number 1, we can also send a request to worker number 10. Because we know that both machines have the same data, like that part of data at least is from both machines, the shard events underscore 1. We can send the request to both machines, and then whichever machine replies first, we go with that. So like that's used in some data computation systems like Spark and Hadoop, for example. Google have also mentioned using that internally in a bunch of places. Cool. So that's the fundamental concept. The cool thing is that it's a pretty general pattern. Like these are the basics, but like a lot of things are built on them. Like for example, Kafka, which is a distributed lock system, is like you have a lot of topics where you can send messages. Each topic is sharded into partitions. And each partition, like this is the partitioning or sharding, and each partition is replicated on multiple machines for resistance. HDFS, the Hadoop distributed file system, and also GFS, which was Google's original distributed file system. They store large blobs, like large files. For example, you have a 10 terabyte file and you want to store it somewhere. Those are also split into chunks or blocks of, like, for example, 100 megabytes or like 128. And each block is replicated on multiple machines for failures and for more efficient management and all that. And this is also the case with more production-ready or like commercial systems like Google's Spanner, Amazon's Dynamo, PB, which are like classic examples of distributed systems. Cool. But then the thing is that, as we mentioned, the failures, like they're constant failures, and also the network is like, can be, one of the fundamental concepts in building distributed systems is that the network can be very, very, very slow and unreliable. So like at any single point, we can have just random packets from the network dropping. Or we can have a network partition, which means that like one part of the data center can talk to each other and the other part of the data center can talk to each other, but they can't talk to each other. So what are the kinds of things that we need to think about? What are the trade-offs that we possibly need to make? We'll start with something called the CAP theorem. It's like a classic result in distributed systems, which says that a system cannot be both consistent and available in the presence of network partitions. So I've bolded all these words because they have like very, very precise theoretical definitions in the proof of the theorem. And they also, like the proof applies in like very specific, well-defined theoretical models. So like I'm not gonna give definitions here because like most people are not really big fans of theoretical definitions. But like keeping that in mind is important for like understanding how new systems deal with those kinds of failures and how some new systems supposedly beat the CAP theorem, which has been a claim lately. Okay, so what is the CAP theorem? What does it mean that you can be consistent and available in the presence of network partitions? So let's say you have like a very simple setup. We have two machines, and both of them are storing the same number. They're storing the integer x, and initially it has the value 0. And then we send an operation which ends up at the first worker, which says write the value 5 to x, set x equal to 5. And worker 1 applies that operation immediately. But then the network partitions, and it can't get to, oh, the other part also says worker 1. I see that now, okay. The other worker 1, the worker 1 on the right, doesn't get the message, so it keeps having a value of x equals 0 because the network is partitioned. And so now when we get a read operation, like if we, at this moment, we get a read operation which ends up at the other worker, like imagine it's called worker 2. But if we get an operation that says, I want to read the value of x, we have two options here. We can be consistent, which means return the last, like informally it means return the last value that was written within the whole system. In our case, that's 5. And because we don't know that this is the value, we need to detect that and not like return an error, give up and say, okay, I can't service this request because there's a network partition right now. That's a consistent option. And then there's the available option. The available option says, informally again, if I'm up and alive, like as a machine, then I need to send a response to this query. So what am I going to do? I'm going to say, okay, x equals 0, which is going to be wrong, like from the perspective of the whole system, but maybe it's still valuable to be up. Okay, that's like the basics. And this is like kind of a simple example, but it also applies to much larger systems. But the thing is that there's like a lot of nuances. Like this is the simple claim. In the presence of partitions, you can be both consistent and available. There are a lot of nuances that matter in terms of how we build or choose systems that this theorem applies to. So one of the first nuances that you hit once you start thinking about it or like reading about it is notice how I code this with 2 letters, like consistent is CP, which means that in the presence of partitions, the system is consistent, and AP means in the presence of partitions, the system is available. So basically, it's like from the CAP theorem, from consistent, available, and partition tolerant, we can only choose 2. So we choose either AP or CP. And so one of the classic jokes is consistent and available systems, also famously known as I don't know how networks work. Because if you say that your distributed system is consistent and available, that means that you're implying that there are no network partitions, which is like currently reportedly impossible from most of the claims on distributed systems and networks. And then the other, like the strictly theoretical question is, if there is a partition, what does your system do? Because like as we saw, it's theoretically impossible. You can't know the value of x on the other machine. So yeah, like I said, there are a bunch of new recent systems that claim to be CA, so consistent and available. We're possibly going to cover how that could happen while still not violating the CAP theorem. Cool. Some more nuances. Like I mentioned, consistency and availability are defined in like fairly strict terms. So once you start building or using such a system, like realistically, most people are not going to build a distributed database system, but a lot of us might need to use one. So you need to make the choice. Do I need to use a consistent system or an available system? But then you also need to get into the nuances and think about, okay, do I need consistency in the way that it's defined in CAP? And do I need availability in the way it's defined in CAP? So one famous example is with Amazon's database called Dynamo. This is one of the first like more famous papers on distributed systems in the real world that made this trade-off. So the interesting is that for business reasons, they decided that they don't really need to be consistent. And what does that mean in their case? I've underlined a part of the sentence here, but the shopping cart service must allow customers to add and remove items from their shopping cart, even amidst network and server failures. That basically means that for Amazon's business, it's very important that whatever ends up in your cart stays there, whatever happens to your servers and your data centers at that point. And one detail that's like even more interesting for me is that they decided that like if there's a partition and they become inconsistent, so that like all the requests can still arrive. Like after the partition is done, you need to somehow reconciliate, like decide what should actually be in the system, like what's actually in a user's cart if they added things and removed things during the network partition. So they made a decision that when merging these things, they merge add to cart operations, but they might ignore remove from cart operations. So what does that mean? It means that if you have the same user doing this sequence of operations, like open one session, add item, like some book or like some router to your cart. I want to buy item X. And then like 5 minutes later, you open your browser again, but you hit a different Amazon server. And that different server is partitioned from the first server, so it doesn't know that you added X. And you say, oh, okay, I want to remove X from my cart, and I want to add Y. I found a better router, so I don't want to use buy the previous one. I'm going to buy the second one. So Amazon says, okay, I'm going to add Y to your cart. And then when the partition is over, you end up with a cart that says, oh, he's going to buy X and Y. Because Amazon doesn't want to lose additions to your cart, because those are like those bring in business, but they are willing to lose removals. So like Amazon are fine with you having to remove a router from your cart because you added it by mistake, but they're not fine with you having to add it again. Like they don't want to lose business by this. Okay, so then another nuance is, okay, so you decide, okay, during network partitions, I want to be available. But most of the time, there's no network partition. Like network partitions are a failure mode that needs to be handled generally, but like they don't, realistically, they don't happen most of the time. So what about during normal operations? And one interesting thing is that lots of databases sacrifice consistency even without partitions. Classic examples of this are MongoDB, Cassandra, Amazon's Dynamo that we just discussed. Even single node systems like PostgreSQL can sacrifice consistency in the default isolation level if you don't explicitly do something to change that. So why do databases like this sacrifice consistency when there's no partition? So like the network is all working fine, but there's still no consistency, still no transactions, still no asset in the classic database terminology. Well, it turns out that transactions are like very hard on your latency as well. So as soon as you introduce transactions, all the operations in your network database possibly start being very slow. So like transactions in the distributed database can be very slow. So a professor from, I don't remember where, but his name is Daniel Abadi. He's like very famous in the database world. Introduced a theorem called PASELC, which is not as sketchy as CAP. So I'm pretty sure that's like part of the reason he didn't catch on as much. But it says if there's a partition, you need to choose between availability and consistency, which is the part that we saw so far. But then if there's no partition, else, you need to choose between latency and consistency. So if you choose to be consistent, even when there's no network partitions, all of your operations might start being very slow, and you can incur a lot of latency on your database. Cool. Another problem that, or trade-off that needs to be made is when you need to do cross-shard operations, like joins, group by distincts, or a trickier thing is cross-shard transactions. So just as a quick example here, if you want to do a select count of distinct IDs from this table, I'm not going to go into this in detail, but if you think through this, like how this query can be executed, you're going to realize that because all the IDs are distinct, here we can do something simple. Like we can say, oh, there's like 100 million distinct IDs on each machine because we partitioned by ID. But if we had partitioned by something else, we would need to accumulate all the IDs on the central machine and just do some operation on them, like union all the sets, like have a single machine be doing a ton of operations, being a single point of failure in our operations. So like that's also another trade-off that needs to be considered when you're introducing sharding and partitioning into your system. This all sounds pretty theoretical, but an interesting thing is that it's actually not. Like I said, most of us are probably not going to be building distributed systems, but a lot of us are going to be using them in some form or another. So I'm going to give two examples. One is like very specific and concrete, and the other is like more of a meta example. But like the specific example is that AWS S3. How many of you have used S3? Okay. Yeah, so S3 is eventually consistent. So when you insert an object, it doesn't immediately become known to like other participants in the system. Like there's one very specific case in which it does, but like in all others, it doesn't. So we can do something like write a new object. Like this is from the docs directly, but I've highlighted some parts. But a process can write a new object to Amazon S3, and immediately list the keys within this bucket. Like this is all the same process. Like we don't even have distributed. Like we don't have parallelism within our system. We're just using S3 from a single process. So we can list the keys in the bucket, and until the change is fully propagated, the object might not appear in the list. And then the other is, a process can delete an existing object and immediately try to read it. And Amazon S3 might return the deleted data. So that means that the sequential execution of logic that you're used to from single-threaded programs, like I'm going to delete this object and I'm going to try to read it, and it's all going to fail. This is wrong if you're using S3. Or if I write this new object and then I list the directory in which it is, it's like a bucket in Amazon S3 terms, but it's like a directory. But I can do that, and the object may not be there. Like it might be there, but it may not be there as well. So like part of the concerning bit is that it's called eventual consistency, which means that if you don't write, like if you stop changing the object, eventually at some point in the future, all readers will converge on the same value. But there's like absolutely no strict guarantees on when this will happen. So in theory, it could be seconds, but in practice, it could be hours. Or I'm going to say in practice, it can be multiple minutes, because I'm pretty sure I've seen that happen. In theory, it can be hours, because Amazon doesn't give you any guarantees. And the meta example is something called Jepsen. How many of you have heard about Jepsen? Okay, so Jepsen is a very cool, the part that's most familiar to me is like a very cool series of blog posts. But it's like a system that's used for testing distributed databases. A guy called Kyle Kingsbury wrote it, and he's like experimenting with different distributed and non-distributed databases and testing if they do what they say they do. So like, for example, if a database says it's consistent, Jepsen is there's a system that's part of Jepsen that can run multiple tests on it and see if it's actually consistent. And they're like, if you have time, I would advise you to go there, and like if that's an interesting topic to you, they're like very popular databases that are tested there. I'm going to give just one specific example. Kafka. So just like, how many of you have used Kafka or are familiar with it? Okay. So Kafka is like a distributed log, like I mentioned a bit earlier. But the idea is that you just send messages to it and it writes them, and it writes them in a durable way, in a very performant way. Supposedly they're like durable, but here are the results from the Jepsen tests of Kafka. Like there's like one caveat, which is that this test is from maybe 6 years ago, so things changed since then, possibly. But what happened when they were testing it is that Kafka acknowledged, so like basically what happened is that they started a Kafka cluster, and they started sending messages, and then they partitioned the network. And like Kafka had to make this choice. Do I want to be available or consistent? So Kafka made the choice that, like supposedly Kafka, according to the docs, makes the choice to be consistent and available, which like we saw is usually a fraud. But what happened is that between 98 and 100% of writes were acknowledged. So Kafka said, oh, that's okay, I wrote almost everything that you sent me to persistent storage. And then after the partition recovered, so like they connected the network back again, there were 520 acknowledged writes that were lost. So you say to Kafka, okay, I want to write this message. And Kafka says, oh yeah, cool, it's done, I wrote it. And then like 2 hours later, your network recovers, gets in a better state, and Kafka realizes, oh, you know, these messages were not actually written in my internal definition, so I'm gonna get rid of them. And you lose like 50% of the messages that you send in a failure scenario. So like I said, there are a lot of different tests for this. There's a test for Redis, which is also pretty fun. If you're interested in this subject, I advise you to go ahead and read this. Okay, extra credit. We have a few different options that we're not going to be able to cover. Okay, I'm going to talk about erasure codes. How many of you are familiar with erasure codes or Pete Solomon or something like this? I see one person maybe. Okay, the idea with erasure codes is that you can use some kinds of like linear algebra and like more complicated things to encode some relationships in your data, and you can do that with the idea that you can make the data more reliable. So, for example, you can do stuff that's like for every read Solomon codes allow you to add 4 bits to every 10 bits, for example, in a way that you can actually tolerate the partition of like half the original data, tolerate the loss of half the original data. So like that can save a lot of storage space in comparison to the replication, which was just like, I'm going to copy all the shards over. The idea is I'm going to use some complicated math, or not some complicated, but I'm going to use this math in order to replicate the data in a way that's more efficient. And okay, a couple of tidbits, like how do you beat the CAP theorem? Like there are a few systems lately. One is Apple's Foundation DB, one is Google's Spanner DB that claim to beat the CAP theorem, which like you said is like kind of hard because like how do you know the different values if there's a partition? So one interesting thing is that they usually beat it by slightly changing the definitions and slightly changing the rules. Like for example, Apple's Foundation DB says something like on the docs, something like this is like what we do is high availability as usually understood, but it's not availability in the CAP sense, which is like more accurate and slightly different, but in the end, like in strict CAP terms, it's still a consistent and partition tolerant system. And Google Spanner, they basically build a system that's like so stable, like the network is so stable that they basically assume that it never fails. In fact, it turns out that it does fail sometimes. And when it does fail, Spanner is going to choose to be consistent instead of available. So it's also a CP system in CAP terminology. That's like just a quote from one of the guys that actually created the CAP theorem, which just says, the short answer is no technically, as in is Spanner a consistent available system, but yes, in effect, and its users can and do assume CA. Okay, yeah, that's about it.
Awesome. I think we have time for questions, so raise your hands if you want to ask something. Any questions? Oh, there is a question. You ready?
So, hi, thanks for the talk. It was very interesting. You spoke a lot about scaling data in order to be able to store more data. Do we need to scale data in different locations? What can you tell us about that?
Like scaling between data centers?
Yeah, there's in different locations. Like, how do we decide what data to store in different locations?
Sorry, can you elaborate? I'm not sure what exactly the question is.
I mean, do we need to have different databases that are stored in like different parts of the world?
Oh, got it. I mean, yeah, some databases do that. That's what's usually called data center replication. Like, for example, Amazon and Google definitely do this for some of their more important services, maybe for most. Like, the idea is that there can be, like, there are a lot of energy outages right now in California. So there could be like a data center outage, something that affects your whole data center. So in that case, you need to fall back to a different data center. But that's like in the case that you're Google or Amazon. For most like smaller companies, it usually adds another layer of complexity to what we talked about in the last 40 minutes, or 30 minutes. And like if you can, basically there might be ways to make the problem simpler. Like for example, in the company that I work at, one of the core components is data collection. So we collect data from various sources. So that's I think the only part of our system that's data across data center. So if a single data center fails, we're still going to keep collecting data because that's very, very important to us. Like not losing data is very important. But if we lose a data center where our UI backend is hosted, for example, people are not going to deal with us. It's the application. I don't know if that answers your question.
Yeah, I guess.
Okay.
Can I ask something that adds a little detail on that?
Okay.
Does it make sense to scale data given the business case? I mean, if we have a software that scales around the whole world and maybe some data is important to different parts of the world, does it make sense to scale it in a way that we optimize storage?
Yeah, it could. Like, for example, a possible thing that you can do is, in order to minimize the latency that it takes to get to your data, for example, I think Facebook does this, probably other places as well, definitely. But like one thing that Facebook sometimes does is it keeps copies of your data in a data center that's closer to you. Like, for example, if I'm accessing Facebook right now, I'm probably not going to hit the data center that's in the Western USA, but I'm going to hit like one that's in Europe because it's just going to take like a smaller network latency to get there. Just because at some point you're fighting with, like you just need to get this data from one end of the world to the other if it's at the other end of the world. So yeah, you could make sharding that's like focused on different parts of your user base.
Okay, thank you.
Here. Any other questions? Oh, there's one. Please stand up asking the question.
What are your thoughts about CockroachDB? Do you think it can you use it like Google Spanner?
Sorry, what's the question?
What are your thoughts on CockroachDB?
CockroachDB? Yeah, from what I've read, CockroachDB is based on the Google Spanner paper, but it doesn't have two important components. One is the network in like Google's physical network in the data centers. So like this paper that I quoted by Eric Brewer, which is literally the person that created the Theorem. So like he works at Google now, so probably not completely objectively, but like the paper goes at length through the fact that a very important part of making Spanner close to CA is the network. Like the network is extremely reliable. They have like out of each data center, they have like 3 network connections to the outside world within the data center. They also have like a super reliable network, and they also have like atomic and GPS clocks and all that. From what I've read, CockroachDB doesn't have all this, so I don't. As far as I understand, they can't claim to be consistent and available just because network partitions are not in their control, because they're like the software. It might be like, I don't know if they have a hosted solution, but in general, if you deploy CockroachDB on your own data center or in AWS or whatever, which has network partitions, you're not going to be able to fight with that. But I think it is like a consistent and partitioned tolerant database.
Right, we have time for one last question. All right. So, can you tell me the question and I'll live translate?
He mentioned that not losing data is very important, and I imagine the inverse is also a problem, where you receive data more than once. And
There's a microphone, sorry.
Oh, thanks. Did you hear my question, or should I repeat?
I heard parts of it, but
Repeat it for the stream, please.
Okay. So you spoke about that it's important to you not to lose data, and I imagine the inverse is also a problem where you receive data more than once. So I was wondering, is exactly once delivery possible or a problem?
I mean, based on all the theory, exactly once is not possible. Like, there have been claims lately, like Kafka claims that they have exactly once. It's like a very limited way of defining exactly once because they have exactly once within Kafka. So like, the main problem with exactly once is that once you have side effects, you can guarantee that these side effects only happen once. So for example, if you're trying to send an email in response to a message that you received once, you can be 100% certain that you did or didn't send the email. So if you receive the message again, what are you going to do? Or like, I guess the more accurate way to describe it is, if you fail to receive acknowledgement of the sending of the email, what do? Do you give up or do you retry? So like if you give up, maybe the email never did get sent. Like you didn't get an acknowledgement because the email wasn't sent. But if you do retry, maybe the email was already sent. And you just didn't get a reply because your network was unstable at that point. So as soon as you have externally visible side effects that go like outside of your isolated system, I think the consensus is that exactly once is not possible. As long as you're within your system, exactly once is possible in some definitions. Like exactly once usually means that I have idempotent messages so I can retry them multiple times. That's what usually people mean when they say they have exactly once. I think that's what Kafka means when they say they have exactly once. But in general, with side effects, it's like impossible, I would say.
Right. So,
thanks everyone.
Again, big round of applause for Ivan. And thank you very much for being here for the first day of the conference. Real quick, bring your water bottles or just bring some kind of water bottle tomorrow because there are going to be dispensers but no bottles. So if you want to drink water, bring a bottle. And tomorrow registration starts again at 9:30. First talk is 10:30, so be here and have a good evening.